Hi, Keith Nichols here at my Kalamazoo apiary. You can see a few of the hives behind me. It's February 4th and we have some stormy weather coming up. Before that hit, I thought I'd do a quick walkthrough, let you take a look at a few of the hives. And if you're watching this, then you're interested in bees like I am. I like talking about them. So I'm going to talk about bee equipment for a bit. And just a few notes on these hives. You can see that there's black building felt on them. And that's so that the sunlight that strikes them from the east side, which you're looking at, and then the south side, shines on the hive, and that'll warm the hive temperature up. If it's freezing outside here, inside will be 45, 50, even 60 degrees. It makes that much difference in the heat gain, and that's important for the bees because the wintertime cluster, if it doesn't have warm temperature in the hive, is pretty much stuck in one place, and they'll quickly run out of food. So the idea behind warming up the inside of the hive with the sunshine every now and then in the wintertime is it gives the bees a chance to move around and go to another location and obtain their food, and that way not starve. So let's go inside now and we'll talk about the hive equipment and specifically the Langstroth hive. Welcome to my wintertime basement shop. Beside me here is a Langstroth hive named for Lorenzo Lorraine Langstroth, an early American beekeeper who patented this hive design in 1852. It has some important features like the ability to maintain bee space throughout the hive. It has removable frames that the bees build their comb on, and that's important so that the hive can be taken apart and inspected, or the frames taken out to harvest the honey that's in them. And it has removable stacking hive bodies that make the same things possible. Now, Langstroth wasn't the first beekeeper to understand that bee space existed, and there were other designs that included movable frames. But he was the first beekeeper to put all of those features together in a single hive design, and that's why he was able to patent it, and the hive is therefore named for him. There are other hives in use. Years ago, thousands of years ago, the Egyptians kept bees in hollow logs, and they've been in use for years. They're called bee gums, and you've probably seen pictures of what are called bee skeps that look like those upside down baskets woven of straw. And there's a British national hive that's very similar to the Langstroth hive, but the dimensions are different. There's the Wary hive that was invented by a French monk, and its design doesn't use any frames inside at all. And there's the top bar hive that use movable frames, but it isn't shaped like this. The arrangement is side to side rather than up and down. But the Langstroth hive is the one that's most commonly used in the United States. The equipment is readily available. It's not the most expensive nor the least expensive hive. And it's just a really good all-around general use hive, and it's an excellent one for new beekeepers to begin with. So that's the one I'm going to discuss today and demonstrate and encourage you to use. The example here that I've shown you is just the way it comes from the seller or manufacturer, unpainted. White pine, typically. It's a nice light wood, stands up to the weather pretty well. But it doesn't last forever, and it lasts less long if it's not preserved some way, either by painting or some other method. Now, here's an example of a hive body that I've just painted. And if you choose to paint yours, or if you buy painted hive bodies, you'll find that the inside should not be painted. You can see from the example this one isn't, whereas the outside is. And that's to prevent the bees from ingesting any of the paint, which wouldn't be good for them. But the white paint is a typical hive body color, and presumably that's because the white reflects the sunlight and keeps the inside of the hive from overheating in the summer heat. Now, the ideal temperature for the inside of the beehive is between 90 and 95 degrees. Bees can draw a comb when the temperatures are 90 to 95. The brood is more healthy and easier to raise when the temperature is 90 to 95. If the outside temperature is less than that, then it delays the bees in raising the brood. It's not as efficient. They can still do it because they can gather in a cluster within the hive and vibrate their wing muscles and generate heat that way to bring the temperatures up to the ideal. But it takes more energy and it's less efficient for the bees. So in the summertime, when it's hotter than 95, they can cool the hive by spreading water around. They put little droplets of water on the comb, and then they fan that with their wings. And they have other bees stationed at the entrance that fan and circulate air throughout the hive to cool things down and maintain the ideal hive temperature. But anyway, the white design is to prevent the hive from overheating in the summertime, or to help prevent the hive from overheating in the summertime. Now, here in Michigan, that's not such a problem. In the southern United States, or out in California, or down in Texas, very warm temperatures are the norm, and in those areas, probably the white hive is highly recommended. But we really don't have that much hot weather here in the Kalamazoo area or southwest Michigan and further north. The bigger problem that we have is the opposite. In the fall and the wintertime, in the fall and the springtime, it gets down below freezing often, and that delays the bees from building up like we want them to. So it's my opinion, it's better to have a dark colored hive than a light colored hive. The dark color absorbing the light from the sun and generating heat inside the hive, help keeping it warm. So I've painted this hive for demonstration purposes, or this hive body for demonstration purposes, but I really think it's more important, instead of white, to have a darker hive body color. And the way I achieve that is to stain this hive with a product that's called ECO wood treatment. And this is available through at least one of the major bee suppliers. That's where I bought this. I also see, if I Google that online, then multiple suppliers come up for it. But I prefer this product, and it costs about $20 for a packet of powder that you mix with water. Makes about 1.5 gallons or 1.25 gallons, and that's enough for dozens of hive bodies. So it'll last you all summer unless you have a lot of hives. So that's what this hive is stained with. It's a bee-friendly, non-toxic stain. I still only stain the outside, and it preserves the wood and generates heat that helps keep the bees warm. Another word on painting hives. Some people like to paint the hives different colors, and the theory is that helps the bees find their home. Bees do recognize colors, And if you have different colored hives or different patterns of color on your hives, then the bees can find that their own hive when they come in from foraging, and it cuts down on a thing called drift, where bees drift from hive to hive. I frankly haven't had too much trouble with bees drifting that I'm aware of, so I keep my hives in different locations. I don't line them up in rows, and I think just the differences in how they're positioned helps them locate the hive that they belong to. And I think smell plays an important part in it too. The bees smell their own hive, and so that's what I can tell you about paint. The first piece of woodenware you're going to build your hive upon is called the bottom board. And this is an example of an 8-frame solid bottom board. And as you can see, it has a solid bottom. There are side walls that are 3/4 of an inch high. And then that's usually the way that the bottom board is placed, with the 3/4 inch side up. Some beekeepers actually use the 3/8 inch side up, and well, there are various reasons for that. If you put the 3/4 size up, then that's going to give the bees about 7/8 of room between the top of the bottom board surface and the bottom of the frames. Well, that 7/8 inch is much more room than they need. And what they'll tend to do is build comb on the bottom of the frames. And the comb that they build in a healthy hive will be drone comb. When they start to raise drones, once the nectar and pollen sources become prevalent. And is that a good thing or not? It makes things a little messy inside the hives, but the bees, when they're getting their nectar and honey, are going to build drone comb somewhere. And frankly, I just as soon have it on the bottom of the frames rather than have them tear out nice brood comb on the surface of the frames and then build their drone comb there. You can always, if you wish, take those frames out and scrape off that drone comb, but since the bees are using it, you might as well leave it there anyway. Solid bottom board. I don't know if you can see the width. This one is 13 3/4 inches wide, and that's an 8-frame bottom board. I like 8-frame equipment in the hive because it's easier to pick up. It weighs quite a bit. Well, it weighs a bit less. A full, deep honey super filled with honey in 10-frame configuration weighs about 90 pounds. And if you're picking that up from the side of a hive, that's quite a bit to pick up, especially if it's raised up any distance in the air. So I use 8-frame equipment mostly. This is an example of a 10-frame. 10-frame equipment is 16 1/4 inches wide, and it's called 10-frame equipment because it will hold, that 16 1/4 inches is wide enough for it to hold 10 frames, just like the 8-frame equipment is 13 1/4 wide, 13 3/4 wide, and it holds 8 frames. So you've got 8-frame equipment, 10-frame equipment. 5 nukes typically come in 5-frame equipment, and I think it's possible to buy other sizes too, but the two common ones are usually 8 and 10 frame, and like I say, I prefer 8 frame because of the weight considerations. Now, if somebody's gifted you 10 frame equipment, you can stick with that. It will work fine, and especially when you're first starting out, it won't be a problem. You may decide later on to go to 8-frame equipment, or if you don't have any equipment, I think it's a good idea, frankly, to start out with 8-frame equipment. So, the screen bottom board, why is it called that? Well, it's because the bottom, instead of being solid, is a screen. And you can see that if I pull out the graduated bottom of the removable graduated bottom of this thing, I don't know if you can see the screen or not. There, I think it shows up. But that screen is number 8 hardware cloth. That means the holes are 1/8 by 1/8, and that's too small for a bee to get through. Well, why did they go to 8 frame equipment? Or I'm sorry, why did they design screen bottom boards anyway? Well, one of the pests that's the most serious one you'll have to contend with as a beekeeper in the United States and over the world is called the Varroa mite. And these screen bottom boards were instituted because it was believed that the bees groomed the mites off of each other, and if the bottom of their hives were screened like this, then the groomed mites would fall through the screen onto the ground, and then that would reduce the number of Varroa mites in the beehive. Now, as it's turned out, I think there have been studies done that show something like an 11% reduction in mites with screen bottoms over solid bottoms. And, well, the people who have those figures know a lot more about it than I do, but frankly, I don't find there to be a whole lot of difference in the Varroa mite concentration in hives between screen bottoms or solid bottoms. And why that's so, I could only speculate. But anyway, a couple things that I do believe should be obvious to everybody is that this little gizmo that slides in and out, it's graduated so that you can count mites if you're of a mind to do that. But this thing that slides in and out doesn't do a very good job of preventing cold air and drafts getting into the hive. And that sets the bees back in their production of brood, especially in the spring and fall when the nighttime temperatures are so cold. Now, I think the trade-off is in favor of a solid bottom, frankly. It may mean there's a reduction in mites, but I'm convinced that it means that the hives are colder, and that's why I prefer a solid bottom board. Another device that is associated with the bottom board is called an entrance reducer, and that's this thing here. You can see it has several different sizes of openings cut in it, and it fits on the bottom board like that. And then your hive body will sit on top of that, and this right here becomes your bee's entrance. Now, this is the small entrance. If you're going to reduce it, you reduce it down to this size at times when the hive is just starting out and the population isn't so great. That's important because each hive has guard bees that will keep robber bees from coming into the hive and stealing the honey that's stored there, or hornets flying in and eating the brood. So a small entrance is easier for the bees inside the hive to protect the hive from those kinds of intruders. As the season advances and the population grows and it's more capable of protecting the hive because there are more guard bees at the entrance, and it gets warmer and warmer outside and there's a need for ventilation in the hive, then you can increase the hive entrance size. Actually, it should go this way. And see, the entrance is reduced, but it's less reduced than it is with the smaller entrance. So that's the hive bottom board and the entrance reducer. On top of the bottom board goes a hive body. This right here is a deep hive body, and it's also called, because it's the first one on top of the bottom board, and because this is where the bees will typically raise their brood, it's called the brood box. So it's a deep hive body, also known as a brood box. It's 9 5/8 inches deep, and that fits a deep frame. That's a standard dimension. and it goes on top of the bottom board with the entrance reducer, just like that. Now I mentioned frames. Let's talk about frames for a little bit. This happens to be a shallow frame, and the bees have just started to draw out some comb on this. I don't know if you can see that too well. And it shows up a little bit, but it's a shallow frame, and the frames are what the bees build their combs on and raise their brood on and store pollen and honey and all those kind of things. So the inside of the hives are filled with frames. Now, I like to buy my frames with the frame itself already assembled and come in packs of 10. Pretty reasonably priced this way. You can buy just the frame itself, the frame pieces, and assemble them yourself. I used to do that, but I found that it takes a whole lot more time, and now I just buy them already assembled like this. This is a deep frame, and it's built for this 9 5/8 inch deep hive body. On the frames, we typically put some type of foundation. This happens to be wax-coated plastic foundation. It's already embossed with the cell sizes. I like to use plastic, solid plastic foundation like this because it stands up better in the extractor when you spin it to get the honey out. And also, when you're storing it in the wintertime and it's frozen, it isn't as fragile, and it's easy when handling or storing the wax frames, all wax frames, to put your finger through or have the frame fall against something and it blows a hole right in the wax. I'm just going to show you how this pops into the frame. There's a slot in the bottom of the frame, on the top side of the bottom of the frame, and you put this plastic into that slot, and then you just pop it into the groove that's in the top of the frame, just like that. So there's a frame with plastic foundation. Now, when I first started out, I thought it would be more natural and the bees would like it better to draw comb on an all wax foundation, and that's available. It's got wires running through it that make it stiffer, a little stiffer, but I've found over the years that it's still prone to damage, and I like to use the wax plastic foundation like this. And you can see that fits right into the deep hive body. I mentioned before that there are 10 frame and 8 frame configurations that are the common sizes. Both the 10 frame that's 16 1/4 wide and the 8 frame that's 13 3/4 wide have the same length, the same distance this way. And that's on the outside to outside 19 7/8. And that way any of the frames will fit into any of the hive bodies that are the correct depth for those frames. Picture this. Things are busy inside the hive. The queen is crawling over the frame. The attendant bees are crowded around her, and she's found a spot she wants to lay an egg, so she reaches her abdomen down into the cell and lays that egg. And she leaves the cell, and that egg's down there and is standing upright. So 3 days go by. The egg has gradually laid down, and internal changes take place within the egg, and after 3 days it hatches, and now it's a larva. And the larva is in the cell, and the nurse bees are paying strict attention to it, and they're feeding it for the first 3 days royal jelly, but after that regular bee food, because I'm talking about a female bee, a normal hive bee, not a drone, not a queen, but just a regular bee. So the regular bee is now a larva, and it grows larger and larger in the cell, and that takes place for 8 days. So first 3 days it's an egg, the next 8 days it's a larva. At the end of the 11th day from the time it was laid, the nurse bees cap the cell with wax, and that larva spins a cocoon around itself and turns into a pupa. And the bee remains a pupa for an additional 10 days. So from egg to larva to pupa to hatched bee takes 21 days. Drone takes slightly longer, 24 days. And queen is less time, 16 days, but that's the way it works. We'll say for the purposes of this discussion, we're talking about 21 days for a bee to go from an egg to an emerged bee. Well, the nurse bees get busy and clean that cell out and prepare it. They polish it, and it's all ready for the queen to lay another egg. And that, we'll say that takes another day. So we have a total of 22 days in the cycle of a cell from the time it's used until the time the bee hatches out and it can be used again. If you take that 22 days and multiply it by the queen's ability to lay 3,000 eggs a day, then that means your brood box needs to have the capability of holding 66,000 individual cells in order for the queen not to have to wait to use a cell because none are available. So the key figure is 66,000 cells in your brood box. If I take a frame of foundation and count the number of cells, counting up and down and then across, and multiplying those out, I find that each side of each frame is capable of supporting 3,600 cells. So there's space for 3,600 cells on each side of this frame. And since each frame has two sides, that gives me 7,200 cells per frame. Okay, so in an 8-frame configuration, I have 8 frames per hive body, and each frame is capable of holding 7,200 cells. If I multiply 7,200 times 8, I get 57,600. Yes, 57. I had to think that through. 57,600 cells in an 8-frame hive body. Whoops, but I need 66,000 to not impede the queen from laying. So that means that if I'm using 8-frame equipment, I need a double deep brood nest. I need 2 hive bodies in the brood nest. That's going to give me far more cells than I need for a brood nest, but that's not a problem. The bees will use those spaces for other things besides raising brood. But the point is, a single brood nest, a single hive body, won't be sufficient for an 8-frame configuration. But what about my 10-frame brood box? Well, 10 frames times 7,200 cells per frame gives me a 72,000 cell capacity. And so for a brood nest, 10-frame equipment, a single deep hive body is sufficient. Well, here's a piece of equipment that not everybody uses. I tend to favor it, but some people think it's completely unnecessary, and to some people it's an impediment. This is known as a queen excluder. Those who believe that it's an impediment call it a honey excluder. But you can see that there are small holes in here, and these holes are large enough for a bee to pass through, a worker bee to pass through, but they are too small for a queen or a drone to pass through. And the way this is utilized is that it's placed on top of the brood box, and other honey supers are placed on top of that. And that keeps the queen from going up into the hive where the honey is stored and laying eggs and raising brood in among the frames that you would want to keep for honey. I've not found it to restrict the bees from storing honey above the excluder. Some people are convinced that that happens. I'm not convinced. I prefer to use them. It also keeps the queen in a location in the hive where she's more readily found if for some reason you need to locate the queen, like you're doing a split, or you want to check and see whether there are any queen cells being raised in anticipation of the hive swarming. It makes it a little easier to locate the queen, and keeps your honey cleaner so that you don't have to contend with having brood in the cells that you're going to extract from. This right here is a medium super, a honey super, a medium hive body, and a medium hive body is 6 5/8 inches tall. And of course it has a frame that's not as deep as a deep frame, and it's built specifically for this 6 5/8 inch tall hive body, which is called in the trade a medium super. So that goes on top of your brood boxes. Now on top of that is another super that people sometimes use called a shallow super. And a shallow super is 5 5/8 inch deep, and it has corresponding frames that fit that super specifically. I have that to demonstrate, and I'll put that on in a minute, but first I'd say that I bought that for the demonstration. I don't like to use them because it just complicates the inventory of equipment that you have to keep, and I'm going to all medium supers rather than shallow supers. But I'll show you that in a minute. This is a shallow super, and it has a depth of 5 5/8 as opposed to 6 5/8 for a medium super. It has a frame that corresponds to it in depth. This is a shallow frame to go with the shallow super. So we have deep hive bodies. The bottom one, also called a brood box, on an 8-frame setup. The bottom two are called a brood box, or used for brood boxes. But both of these are deep hive bodies. This is a medium hive body, or medium honey super. Use the term interchangeably. This is a shallow honey super made out of a shallow hive body. So I hope that's clear. This right here is the next structure to the hive. This is called the inner top cover, and it's the same dimension as the exterior dimension of the hive bodies. This is an 8-frame interior cover, excuse me. So it's 13 3/4 wide by 19 7/8 long. It has this vent hole here, and it has what's called a bee escape out of the front. Now the bee escape always goes up because the depth dimension at the bottom of the top inner cover is 1/4 inch. And then there's an 1/8 of an inch between the top of the top hive body and the top of the frame as it rests in the hive body, which gives you 3/8 inches, which is that magical bee space. This notch is 3/8 inches by 3/8 inches. That's bee space once again. The top dimension here is 3/4 of an inch, 3/8 of an inch in depth. That's how you have a 3/8 by 3/8 escape hole here. if you flip this upside down, the bees could still escape, but you'd have too much room between the top of the frames below and the top of the inner cover, and the bees would fill that with comb. And then this would be stuck to all the top of the frames and you couldn't get them apart without a lot of trouble. So you put the bee escape up like that. I don't think I've talked enough about bee space, so let's consider that. Bee space is that space that's approximately 3/8 of an inch that Langstroth sought to build into the design of his hive, so that basically every open space within the hive is 3/8 inch or approximately so. Now if the space is smaller than 3/8 of an inch, much smaller, then the bees can't get into it and get through it. And that's important that they are able to do that, because bees are constantly patrolling the hive against intruders. You have ants that get in there or could get in there. You have wax moths that can get in there and lay eggs, and the eggs hatch into larvae. Same with the small hive beetles. The wax moth larvae are a little bigger than the small hive beetle larvae, but they all get into the comb that has honey or brood in it, and they start tunneling through that comb, eating up the honey and defecating on the inside of the hive. That causes mold and yeast to grow in the honey and bacteria, and it forms a slime, and that if it gets out of hand can destroy the inside of the hive. The bees will vacate, and the whole work of the bees for all summer long will be ruined. Oh, you don't want that. You want to keep those critters out of the inside of the hive. Well, the bees will do a good job of that. They'll patrol the inside of the hive, and they'll chase out those intruders any way they can. And in order to do that, they've got to get around to any space within the hive where those intruders could insert themselves. If the space that's there is too small for the bee to get into, the smaller ants and small hive beetles can wedge themselves in there, and the bees can't take care of them. So sometimes if that happens and there's not too many of them, the bees can wall off those spaces with what's called propolis or bee glue, and that keeps the intruders under control. If the space is too large, then larger than 3/8 of an inch, or it violates bee space by being too large, then the bees are inclined to build comb in that area and then fill that with honey or brood. And that also makes it more difficult for you as a beekeeper to remove the different supers and remove frames and inspect things and do what you need to do inside of the hive. So you want to maintain that bee space, because if you don't, the bees will either fill it with comb, or if the spaces are too large, or they'll block it up with propolis if the spaces are too small, because they know that they've got to get in there to be able to get in there to get rid of these pests. And it needs to be 3/8 of an inch, because that way they can get side by side of each other and take care of the brood where they need to, and the queen can move around adequately, and the drones that are larger can move around inside of the hive. So that's bee space. So by placing the top cover with the notch up, the bee escape notch up, you'll maintain the proper bee space above the top frames. Top of the inner cover goes this device called the telescoping outer cover, and it's called that because it sits down over the top of the inner cover, and the sides of the outer cover slide past something like the portions of one of those old-fashioned telescopes that the sea captains used to use, slide over each other. So this is a telescoping outer cover and the inner cover. Now, some beekeepers I've seen use just the outer cover. Well, before too long, as you keep bees, you'll realize that the bees fill any vacant space between any of your woodenware with propolis, and it's sticky, and it makes it hard to get things apart. So if you just use the telescoping outer cover instead of using the inner cover also, the bees will glue that down, and there's not really a good way to pry that up. You can stick a hive tool in the gap here and force it up, but you're digging into the side of your hive to do that. Besides that, there won't be sufficient clearance above your frames and the bottom of this cover for the bees. You won't maintain bee space, and the bees will fill that with propolis and also stick your top of your frames to your inner cover, or tend to do that. It won't happen all the time like that, but that's a possibility. And then your frames will get stuck to here, and it'll be that much harder to get the whole thing apart. So that's the inner and outer cover, and those are the components of the hive. Let me show you one more thing. Oop. It's a good idea to put a weight on top of your top cover. Okay, I'm going to talk about one more thing that I believe is very important, and it's a step overlooked by a lot of beginning beekeepers, and that is preparing your site and a hive stand. Before I talk about site preparation and hive stand, I just remembered something else I wanted to say about top covers. When I first started beekeeping, I saw some examples in stores and catalogs of a top cover that looked like this, like the roof of a house. And I thought, boy, is that snazzy. So I bought one and built some others. And I was just sure that the bees would rather live in a hive that looked like a home, a house with a real roof, instead of just a flat old piece of thing that this represents. Well, it didn't take me long to figure out that the bees didn't care one way or another, but it was very inconvenient for the beekeeper. You see, when you take a hive apart to inspect it, the very first thing you do is take off the top cover, and you're going to need some place to put the hive bodies that you take off from the hive that are under the top cover. So you take the top cover off and set it on the ground next to the hive, and then proceed to take your hive bodies off and turn them a little bit like that so they rest on something flat and solid as you take the hive apart. Well, if you try to do this with a roof-shaped top cover, then this thing is going to be tipping one way or the other because of the two pitches on the roof. So it's much more convenient to use the flat surfaced outer hive cover than the artsy looking and homey looking it's called a garden hive cover is the name of it. You know, what's important to you? if the artful looks of the garden hive cover are more meaningful to you, go for it. But I find from a practical standpoint the flat roofed hive cover to be superior. So what the heck am I showing here? This is an example of something that I neglected to do when I was a new beekeeper, much to my regret. I didn't put ground cover, ground cloth, or weed barrier down underneath my hives when I placed them, and consequently all summer long I had to contend with weeds growing up in front of my hives and having to cut that back while the bees were buzzing around me, and that was no fun. So be sure that when you place your hive stand outside, you put something down for a weed barrier. Now, the concrete blocks are basically a hive stand to raise the bottom of the hive up away from the ground, where it will prevent the equipment from getting wet, soaking through by constant contact to the ground. And it gives it a solid place for the hive to sit. You don't want to have the thing tippy when you go to do your manipulations. So you want a solid base, you want it raised up off the ground. You don't want to spin an arm and a leg for it, although there are some people that don't mind that. They make a very fancy plastic one that it's really the Cadillac of bee stands, and you can buy those for about $70 to $100, and they have built-in frame rests and all that, but I find this to be sufficient. The blocks cost about $1 a piece. The ground cover can be something as simple as old building felt. This is a piece of commercial roofing that I got from my son-in-law. So you put the ground cover down, you put the blocks or whatever you're going to use for your hive stand on top of that. If you use these hollow concrete blocks, and make sure the holes are horizontal and not vertical, because otherwise it'll fill up with trash and make a home for critters. And then you spread mulch on top of that, and again that keeps it clean around the hive and keeps the water from splashing and mud developing. You don't want to have to walk in the mud. So you've got your hive stand, you've got your mulch down, and then you start building your hive. There's your bottom board. Your brood boxes, your entrance reducer, any hive bodies that you want to add, your inner and outer cover, and there you go, voila, you've got your hive. Now, I showed all of those being added at one time. You really don't do that. There's a sequence you should add those things in. You don't start out a new colony with all of that space, but that's another course of instruction, so I'm not going to get into that. But I think you get the idea. Thanks for watching. Good night, Mrs. Calabash, wherever you are.